Hello. This is a video recording of applying the Wilcoxon test. I'm going to use the AQA S3 January 2012 question 2 as an example. Let's start by reading the question and highlighting the key points. And you should underline these when you're doing the question. So, first sentence. The gross annual salaries for medical specialists working in the EU during 2003 were investigated. The median gross annual salary for medical specialists in the UK during 2003 was found to be £81,050. The gross annual salary converted into pounds for each of 9 randomly selected medical specialists working in France were recorded as follows. So here's a set of data that we're going to use. Now let's look at the test, and that's the final part here, and it's very specific. Carry out a Wilcoxon signed rank test using the 5% significance level to investigate whether during 2003 the average gross annual salary for medical specialists working in the UK was greater than that for those working in France. So that's pretty straightforward one, that, isn't it? That's as clear as you can get. So let's start. First thing we always do in hypothesis testing is writing our test. So H0, our null hypothesis, and in Wilcoxon signed rank testing we're always starting from the median are the same. The medians are the same. Medians are the same, they're going to be equal. So in this case we're saying that the average gross annual salary in the UK equals that in France. No different. And that allows us to carry out the Wilcoxon calculations we're going to do. Now, for our H1, our alternative, they've given it to us here, and we can see that from the wording, but we had choices usually. So we can have it that it's not equal to, in which case we've got a two-tailed test, or it can be that it's greater than or less than, in which case we're on a one-tailed test. In this case, they've told us that the average gross annual salary in the UK, we're investigating whether it's greater than that in France. So that's going to be our alternative, that it proves that the test in that the salaries in the UK are higher than those in France. So now let's go on and do our test statistic. And as is implied by the name of the test, we're interested in the signed rank of the data. So we've got to go through and we've got to rank it and we've got to sign it, and then we're going to sum it all up. And if you need to, it's written in the tables. We'll come back and pick that up later on. So looking at this data, we're going to compare each item. So the first salary in our list here, 63,520 in France, with the 81,050 in UK, and the difference between the two is 17530. If we follow the same line through for the next piece, the next randomly selected specialist, 64,600 compared to 81,050, we've got a difference of 6450. Now I'm just going to go through quickly and fill those in rather than make you wait. So there are our individual differences for each of the items, or each of the specialists, and now we've got to go through and rank them, and we're ranking them for how far away they are from zero, irrespective of their sign. So our first one, number 1, is this one here with -1150. So that's the closest to 0. The next one on our list is number 2 at 5,550, irrespective of its sign. So, and the third one is 9050. So if I very quickly go through and mark those up, and I'll be back to you in a sec. So there are all the rankings. We've completed that. The Wilcoxon test we've now got to go through and sum up those rankings for the positives and the negatives, and these are known as the T numbers. So let's have a look at our T for minus, and here we only had two minus figures and the ranks for those were 1 and 2, so the total came to 3. For the T plus, we had a large number starting on the left hand end there with the 8 plus the 7, and if we went through and wrote those all out, we'd end up with a number 42. So adding those two together, we get 45. We can check that we've done our calculations correctly, because there is a little formula for adding up 1 to 9, and the total of that, there's a quick formula that says all we need to do is calculate. We know that there were 9 in the sample here in the list, so we're going from, we add 1 to it, 10, 9 plus 9 times 10 divided by 2 equals 45. So that's what it should add up to if we just added 1 to 9 up. So that is correct. So we now know that our calculations are correct, and it's worth doing that because you can lose a lot of marks for little mistakes like that. So now let's take our two numbers down to use as our test statistic. So our T minus was equal to 3 and our T plus is equal to 42. Now the tables, when we get to the table line, says that we're interested in using the lower figure, the lower tail. So our test statistic here will be 3, and that's what we're going to take forward. Our next step is to work out our critical value. Critical value. And we get this from the tables. And this is the Wilcoxon critical value table. Critical value table. And that's table 10, and it's on page 32, AQA, formula book. And I've cut and pasted that down below here for us to use. So let's have a look at what we've got. Here we go. So it tells us table 10, critical values, Wilcoxon signed rank test. It also gives us a hint if we can't remember how to do the test, because it says that these figures for the lower tail, so that means we're going to take the lower number. It also tells us how to do the calculation here, as T is the sum of the ranks and the observations with the same sign. So that told us how to go about doing that sum should we have forgotten. Now, to use a table, we need to pick out a number of items that we've already got. The first one is how many tails. Well, we worked out that it was a one-tail test. They asked to do it in the question, they asked us to do it at 5% level. And the final thing we need to know is n, which is the number of items in our sample. In this case, it was 9. So going across and looking up in the row and column, we get that our critical value equals 8. So we've now got all the data to complete the test. So let's move on and go through and do our test. Here we go. So I'll do that with the purple. And we are going to create our hi-ho line. Now, again, the most extreme value would be 0, because if all the if all of the numbers were above, or our extreme would be a 0, our value of our test statistic would be 0. So think of it, try and think of it that way. Where's the extreme? We worked out our critical value. Our critical value was 8. So immediately we know that. We know our more extreme end, which is going to be our critical region, is from going down from 8 to 0. And that therefore is going to be our area we're going to put our high. And at the other end, we're going to have our ho. So going up above 8 is less significant, less extreme. So if we now mark our test statistic, which was 3, onto this diagram, we find that it's in the critical region. Yeah. So two things we want to write down. On the mark scheme, to get a mark, we want to write test statistic is less than critical value. And we want to write that H0 is rejected. So there we go. Those are our key points. And that completes that part of the test. We also need now to complete a context statement. Now, as we saw, the H0 was rejected. we know we're starting from a statement that goes, there is significant evidence that. And for the rest of it, we just want to shift and lift and shift what they've put in the question. So let's go back to what they asked us in the test, in the question. They said they want us to investigate whether during 2003 the average salary for specialists working in the UK was greater than that for those working in France. So we just basically repeat that word for word into our question. So here we go. I've just written that beyond the dots. The average gross annual salary for medical specialists working in the UK was higher than that in France. There we are. We've completed it. And for that, we get 8 points. Now, finally here, I've just written a very quick summary sheet of the Wilcoxon signed rank test so that you can look it up and write it down. And remember that we're looking at page 32 of the AQA tables, table 10. Will give you the Wilcox critical values and it will give you the formulae in there. So thank you for watching.